Today we're going to be talking about working with polar coordinates and rectangular coordinates, looking at the relationship between those two things, and then converting back and forth between r theta, our rectangular coordinates here, and rectangular coordinates x and y, or Cartesian coordinates. So in order to find the relationship between these two things, we have to look at the relationship here in this triangle and apply some basic rules that we already know. That'll set up some formulas for us. So the first thing we're going to do is apply the Pythagorean theorem to this triangle. That's going to be x squared plus y squared equals r squared. So not only can we use this equation this way, x squared plus y squared equals r squared, we can also write it this way. R equals the square root of x squared plus y squared. So those two equations are going to come in handy as we solve for r and as we solve for x and y. The second thing we can do is we can look at this triangle and apply some basic trigonometry to it. If you apply the cosine to theta, you get cosine theta equals x over r, and therefore x equals r cosine theta. So big important equation there. We can do the same thing with the sine of theta. Opposite over hypotenuse equals y over r, and therefore y equals r sine theta. Okay, so a big important equation there. Lastly, if you look at the tangent of this angle, y over x, if you're trying to solve for theta, theta is going to be equal to the inverse tangent of the ratio y over x. So I have 5 equations here. These 5 equations are going to help me work back and forth between r, theta, x, and y. All right, let's look at the first problem. Find the rectangular coordinates of the points with the following polar coordinates. So this is the equation r theta, since it's polar. So that means that r equals 3 and theta equals pi. So if I want to solve for x, remember x is going to be equal to r cosine theta. So x is going to be equal to 3 times the cosine of pi. Since the cosine of pi equals -1, I'm going to get x equals negative. So x equals -3. Okay. Now for y, I'm going to get y equals r sine theta. So this is going to be 3 times the sine of pi. Sine of pi is 0, and therefore I get y equals 0. So these coordinates, 3 pi, have become the point -3, 0. Okay, let's do the same thing for b. Rectangular coordinates -10 and pi over 6. So I have r equals -10 and theta equals pi over 6. So x is going to be r cosine theta, which is going to be -10 times the cosine of pi over 6. And I get -10 times √3 all over 2. So that makes x equal to -5√3. Similarly for y, I get y equals r sine theta. So r is -10. The sine of pi over 6 is 1/2. And I get y equals -5. So this point has become -5√3, -5. Okay. All right, let's look at some other problems. So now we have our 5 equations, and we can use these to find polar coordinates from rectangular coordinates. So this time, I've got x equals 1 and y equals -√3, and I need to find r, and I need to find theta. So what I know about r is that r is equal to the square root of x squared plus y squared. So I'm going to use this equation right here. X squared is 1, y squared is 3, Therefore, r is equal to the square root of 4, and I get r equals 2. Okay, so I know r is 2. The next thing I want to find is theta. Theta is my angle. So I get that the inverse tangent of y over x, so minus root 3 over 1, is equal to theta. Okay. So I do y over x. That makes this the inverse tangent of negative root 3 equals theta. And that means that theta is equal to, let's see, let's put this in radians. This is going to be 60 degrees in the fourth quadrant, and that's going to be 5 pi over 3. Okay. All right, let's look at B. We're going to do the same thing for B. X equals 0, y equals negative 4, r equals the square root of 0 squared plus 16, and therefore r equals 4. So r equals 4, let's find theta now. If you take the inverse tangent of y over x, you will get your angle. Okay. So where is this going to be? Well, this is undefined. What that means is that the tangent is going to be either here at pi over 2 or down here at 3 pi over 2. Okay. So we're plotting the point 0, negative 4, which is down here, which means our angle is 3 pi over 2. So this has the coordinates r, which was 4, and 3 pi over 2. So it's right there. Okay. All right, let's look at a couple other problems. So these are equations, right, instead of points. You can also convert rectangular equations to polar equations, okay, and vice versa. So we're going to look at some rectangular equations. You can recognize the first one as slope, right? 3x minus y equals 6. It's a linear equation. We're going to convert this into a polar equation. So the way we're going to do that is we're going to use this equation to convert for x and this equation to convert for y. So I'm going to start by converting x. That's 3 times r cosine theta minus y, which is r sine theta, equals 6. I'm going to distribute this. Okay, so this is 3r cosine theta minus r sine theta equals 6. And essentially, I just want to solve this problem for r. So I'm going to factor out this r here and here. And this problem is going to become r times 3 cosine theta minus sine theta equals 6. And then I'm solving for r, so I'm going to divide both sides by 3 cosine theta minus sine theta. Same over here. And I get r equals 6 all over 3 cosine theta minus sine theta. Okay. And once you have an equation that looks like r equals, then that's a polar equation. All right, let's look at B. So before I make any substitutions for B, I'm going to multiply this guy out. So that's going to be x squared plus y squared plus 2y plus 1 equals 1. Okay, and then I hope you recognize this guy right here, x squared plus y squared, here equals r squared. Okay, so we can make a substitution here. So that's going to be r squared plus, I'm going to make another substitution here for y, plus 2 r sine theta, and then I'll subtract 1 from both sides. So that equals 0. Okay. I'm going to factor out r. I get r times r plus 2 sine theta equals 0. And then I'm going to apply the zero product property. That means that either r equals 0 or r plus 2 sine theta equals 0. If r equals 0, you just get the pole. You just get the origin. So that's definitely not what we're looking for. So we can cross that one out. So come over here and solve for r. We get r equals minus 2 sine theta. So that's my equation for r. Okay. Last set of examples. Now we're going to convert polar equations to rectangular equations. Okay, these ones are a little trickier. We still have our 5 equations which we use to look at the relationship, but sometimes we need to do a couple of other things, and these are some techniques that you might try. You might square both sides of the equation, replace something using an identity. You might need to take the tangent of both sides, or you might multiply or factor through by r. So let's take a look at number 4. This one's fairly straightforward, okay? The straightforward thing about this one is that if you square both sides, okay, you should be able to replace r squared with x squared plus y squared. So let's square both sides. We get r squared equals 16, and then we can replace r squared with x squared plus y squared. And that's it. We're done. X squared plus y squared equals 16. If you don't recognize this, this is a circle, which is centered at the origin and has a radius of 4. Okay, let's look at B. Theta equals 3 pi over 4. Here all we have is theta, so if we want to work backward and find x and y, we're going to have to take an inverse tangent of this. So I'm going to take the inverse tangent of theta, the inverse tangent of, I'm going to take the tangent of theta, not inverse tangent. Okay. So I'm going to take the tangent of 3 pi over 4. Okay. And that's equal to 1. And that tells me that y over x is equal to 1. Okay. And if you solve this equation right here, okay, 1 over 1, you get x equals y. And if you don't recognize this equation, this is just a straight line with a slope of 1 that passes through the origin. Okay, we're going to look at 2 more. These ones are a little bit more complicated, but not too much harder. I'm going to scroll up here. All right. So r equals minus 2 secant theta. Since I don't have any formulas that involve the secant, I'm going to rewrite this as r equals minus 2 times 1 over cosine theta. I'm going to multiply both sides by cosine theta. On this side I have r cosine theta equals minus 2. And then I can make this substitution right here. X equals r cosine theta. And I just get x equals negative 2. So this is the equation of a vertical line that passes through the point negative 2, 0. All right, last one. I have r equals 10 sine theta. I'm going to multiply both sides by r. Okay. So I get r squared equals 10 r sine theta. This r sine theta is good to have because I can replace it with this. Okay. And over here, this r squared is good to have because I can replace it with this guy, x squared plus y squared equals r squared. So let's make those substitutions. This becomes x squared plus y squared. This becomes 10, and this becomes y. So what do you do with x squared plus y squared equals 10y? Well, this is also a circle, but you have to complete the square. Let's move this 10y to the other side. X squared plus y squared minus 10y. I'm going to complete the square by adding 25 to both sides. This turns into x squared plus y minus 5 quantity squared equals 25. If you don't recognize this equation, this is a circle. It's centered at the point 0, 5 and has a radius of 5.